All right, so welcome everybody. Thank you for coming. On our final breakout session today, we'll be looking at evaluating automatic voice recognizers for rating non-native, open-ended spoken responses. I'm Marvin Wall. I'm a language assessment consultant for the British Council, and I'll be your host for this session. Our co-host form will also be with us in the background. A quick reminder, please keep your microphones muted, and we'll also be recording this presentation and putting it to our lobby platform later today. And if you want to ask our presenter any questions, please type them in the chat box and our presenter will address them at the end of their presentation. So I'm delighted to introduce Hikanlaya Onchoyaksu, who'll be presenting for this session. Hikanlaya, or Anne, is an English lecturer at the Language Institute, Khon Kaen University in Thailand. She's also a doctoral candidate at Tokyo University of Foreign Studies. At Khon Kaen University, she's in charge of administering an EAP Level 1 course. Now on her study leave, she is exploring her interest in automatic language assessment, particularly assessing spoken production. She's also researching criterion features for automated scoring of spoken responses. So over to you, Anne.
Thank you, Marvin. First of all, I would like to say sorry for the background noise because I'm now at the school in Japan. My internet connection at home is quite bad, so I have to come to school and use the internet here. So I'm not sure what I can do for that, but I am so sorry for that. Now let me start my presentation. I am now doing my PhD at the University of Tokyo University of Foreign Studies, and I'm now doing a research for my dissertation. This research is a part of the small part of my bigger dissertation on automatic scoring of speaking. So, okay, right. So we all know that testing the oral ability is very challenging, but now with the technology, the development of technology and natural language processing, we now have the automatic scoring capabilities that have been developed on purpose of providing solutions to the obvious shortcomings in human scoring, such as the inconsistency, radar drift, and also inefficiency. Basically, the automated scoring system would consist of two main parts, which is the part where we use the machine to transcribe the audio production of the test taker, and then the other part is to score those the production via the transcripts that is the result from the ASR, the automatic voice recognition. Right? The automatic voice speech recognizer, or we call ASR, would generate the transcripts, and then the transcripts would be used to score based on the various scoring models. Right? Which means that the performance of the ASR here has a dramatic effect on the final score as well, because the scoring is based on the transcript that is the result from the ASR. Now, because my research is actually, my bigger research actually focuses on the outcome of this score, right? But the first step, I have to walk through all these problems, or I have to investigate if the ASR is reliable enough, or how well the ASR can work in the whole system. So, and my research is based on what we are the outcome of my research would be beneficial for the university that I'm working for, which is in Thailand. So the ASR that I'm using now would be all open source. So at the first step, at the very early stage of this research, I was finding the open source ASRs, and I found 4 major open source ASRs, which are the Cloud Speech-to-Text by Google, Watson by IBM, Voictra, developed by NICT in Japan, and then Azure by Microsoft. All of these ASR perform very well with the native speaker speech, but their performance toward the non-native speaker remains quite unclear, especially for Thai learners of English, because my university is in Thailand. So I'm focusing on using these machines with the Thai learners. And I also found that Cloud and Watson are the internet-based, and they're quite easy to use, and they can provide a transcript pretty smoothly. Voictra, on the other hand, is a mobile phone application. It works really well with the short utterance, but not the long utterance one. Azure, I had a problem when I tried to use it with my, I have to create my account first, and then after I created my account, I provided my credit card information, and then my credit card was corrupted somehow. So I stopped using Azure. So, and because my research is focusing on the open response, the responses to open-ended questions. So the response is quite long. It's not in a sentence level base. So also Voictra is excluded from this research as well. So this research is mainly evaluating or comparing the performance of Cloud Speech-to-Text by Google and Watson Speech-to-Text by IBM. Before looking at what I did during my research, let's talk about the definitions of intelligibility first, because in this research, I'm focusing on the intelligibility of the utterances and see if the machine could transcribe it or would understand it as well as human. So I adopted the definitions of intelligibility from Darwin and Monroe. They stated that the intelligibility is the amount of utterance that the listener understands. So in my research, I used the same definition as this, and the listeners here, I refer to both human listener and also the ASR. My research question was which of the open source, which is from Google or IBM, would perform the transcribing task more similarly to how human does, and therefore more suitable for the automatic speech scoring system. And the second question is that for further development of the ASR, what types of errors made by Thai learners or of English are often mistranscribed by the ASR. The participants in my research include 3 groups of people. The first one is 10 Thai students studying at Tokyo University of Foreign Studies. I chose them randomly. And then the second group is a pool of the transcriber. It consists of 3 people. 2 of them are professional translators and interpreters, and 1 of them is the native English instructor at a university in Thailand. And then the third group of participants is the native and non-native speakers who I asked to rate the responses from the 10 students. There are 35 of these raters. And the materials that I used for my research is first the basic level, or like simple questions, and it's open-ended questions. For example, what kind of animal do you like and why? Something like that. So I make it simple because I want to make sure that the cognitive loads will not impede their performance, the speaking performance. And I also use 16 diagnostic sentences and 1 diagnostic passage and ask the students to read. The 35 raters are asked to rate the intelligibility of those responses by the students by using the intelligibility rating form, which is a 5-scale subjective holistic assessment. I put it on Google Form so that it's convenient for all 35 raters all over the world to access. And then the ASRs that I use, as I stated, it's Cloud by Google and Watson by IBM. Now, the first step of the first thing that I did for the research when I collected data is I created 10 open-ended questions. As I said, they're all simple, and I make sure that all the words are easy words. So all the students from lower level to higher level would understand the questions that they have to respond to. And then all of them, the students are given 2 minutes for preparation, and then they are told to talk for 1 minute. And then I recorded all the responses on the smartphone. Sorry. Then after responding to the questions, to one question, the students are also asked to read aloud the diagnostic sentences and also one passage. And I also record that on a smartphone. Then after getting all the responses and the read aloud productions from the students, I began the transcribing process. Here, the transcribing are done in 2 ways. The first way is I put on the responses into Cloud speech-to-text and Watson speech-to-text, and then get the transcripts from these 2 machines. And then on the other side, I ask the transcribers, those 3 transcribers, to transcribe the same responses as well. I asked 3 transcribers to transcribe all these the audio files, because I want to make sure that the finalized transcripts that are going to be used is reliable enough. So I compare the transcripts from these 3 transcribers to make sure that at least 2 transcribers agree with each word, and then use the agreed transcript to be a model transcript, so that we can compare the transcript from the machine to this human model transcript later. Now, after I get the transcripts from the machine and from the ASR and from the human transcribers, I started comparing these products, these transcripts together. So I analyze the transcripts by counting the words that are recognized. And so that's why I call it the recognition rate. So the number of the words that the ASR could recognize would be in proportion with the total number of the words. So that's the recognition rate. I know that's a lot of, normally when we evaluate the ASR, we would evaluate it, we would say it has the error how much error rate it is, but because I want to know how the machine could recognize it. So I just make it in the opposite way. I just count the words that could be recognized instead of counting the word that are error. So for the open-ended responses, the responses that answer that the students response to the simple question, we got the EASR transcripts that would be compared to the model transcript from human. But for the diagnostic read aloud transcript, I got the EASR transcript that would be compared to the, not the EASR transcript, but the transcript that I already have, the pre-described transcript. Sorry for my typo here. It's not the EASR transcript. So this is only the sample of how I compare and how I count the words when I compare the transcripts from the EASR and transcripts from human. And then I make some notes on words that are mistranscribed, which you can see the purple boxes there indicates the errors, the words that is mistakenly transcribed. So this is for the open-end response. And this is for the read aloud production from the students. And after counting all of these and comparing and counting all of these, I got the word recognition rate results, which showed that Google could actually recognize more words than IBM. So, and the word recognition rate of Google would be 82.7%, but IBM would be 78.9%. So here at this stage, Google is slightly more accurate than IBM, comparing to how human can work. And also this is the word recognition rate for the read aloud scripts. For the read aloud scripts, we can see that Google performed slightly better than the IBM. So, and this has, I think this has a lot of factors behind that, because when the students perform their speaking task out of their mind, and when they read the scripts are the different abilities. So that also affects the how they speak as well. And I think this is something that needs more research on that. And also, I also asked the 35 raters to rate the intelligibility of those 10 responses, and using the 5-scale assessment. Right? And this is the result of the assessment. I used this to find the correlation between the human perception of intelligibility of those responses comparing to the machine. And at this stage, I found that you can see that human and IBM has higher coefficient correlation than human and Google, right? Which means that somehow in terms of intelligibility assessment, human IBM could perform as more similarly to human than Google. So up to this stage, it was like, okay, Google is more accurate, but seems like IBM could perform as similar to human more than Google. So I did another thing, which is called the agreement of transcribability, which is I compare the words that can be transcribed by human and machine compared to the words that cannot, the words that can be transcribed by either human or machine. So the words that can be transcribed by human and machine, or cannot be by both of them, would be similarity, right? But the difference shows that these words can be transcribed by either machine or human, but not the way around. And from this investigation, I found that Google have higher similarity percentage to human than IBM. Right? So at this stage, I came to the conclusion that, okay, the accuracy of the transcription, Google would be more accurate than IBM, but the correlation to human, IBM outperforms Google. But then the agreement of transcribability shows that Google can transcribe the same words than human. And when human cannot transcribe, Google cannot transcribe either. So so I decided that for my bigger research, I would use Google speech to text because of these evidence. And also for the development of the ASR, I also did analyze the types of the mistranscriptions. So the words that are mistranscribed are analyzed, and I would show you how, this is how I analyzed the mistranscription parts. So the mistranscription part sometimes causes by some deletion, because the ASR just deletes some parts of the response. Either it's phoneme level, morpheme, or delete a word, or maybe some others. So like substitution and insertion. Sometimes the machine just inserts some words in that based on the database that they have. Word boundary also causes the mistranscription as well. And from this analysis, I found that the most frequent transcription or mistranscription types are word substitution and word boundary. The grammatical errors sometimes are being corrected. That's what we don't want at this stage of the whole automatic scoring system, because otherwise it would affect the scoring process at the end as well. So the limitations and the suggestions from my research at this time is that first, the data that I got from the students here in Japan is not really representative, because there are only participants with higher level of proficiency, because they're all international students, and somehow they get their English score pretty high. If I'm going to implement this to my students back in Thailand, I need wider range of levels of proficiency of students. And also the ASR algorithm is being unknown, and well, at least for me. And also the rapid development of the technology would lead to more improved performance of the ASR. The transcript that I got for this research was done like a couple of months ago. So right now it would be something else, right? Because of that. And then the suggestion would be the cooperation between the linguist and the IT, computer, data science, and engineer for developing the ASR that is specifically for specific purpose. And that's the end of my presentation. Thank you.
Thank you, Anne. Yeah, I just wanted to make sure we had enough time for the session. And we, in fact, have a question from Trevor. He thanks you for a fascinating presentation. Trevor asks, did you get any information from the suppliers, IBM or Google, on the coverage of Thai accent in their models?
Not really. I didn't directly contact them, but on the website that I used, for example, for Google, there's we can actually choose the accent. Right? There's several accents of English available, and that doesn't include Thai accent of English.
Okay, and we have another question from Damien. So he has 3 questions. So let's see if you can answer all of them. And the first question is that, do you have any guesses as to why the IBM transcription correlated with human ratings better than Google?
That's what, actually that finding was something that also amazed me, because after I know the accuracy rate of Google being higher than IBM, I thought, oh, okay, maybe I could use Google. But then when I do the correlation analysis, and it turns out that IBM correlated to human ratings better than Google, I was kind of missed as well. And I think it was because, and maybe because when you mean, how can I say, when I compare when I try to find the correlation between human rating and the machine, it's, for the human rating, it's the holistic perception of how intelligible the responses are. And then it compares to the accuracy, like how each word is transcribed by the machine. And I think maybe it was because it's not based on the same parameters, I would say, because this the human intelligibility assessment is on 5 scales, but for the machine, it's counting the number of the words that can be transcribed. I think that might be the factors for that as well.
And the second question from Damien, he asks, what are you going to do about the ASR grammar?
Grammar correcting?
Yes.
Yeah. That's a good question though. And I have been thinking about that so much. Yeah, I haven't found any solution to that yet. As I said, these 10 responses are from the students that is at a quite high level of proficiency. So there are not a lot of grammar correction in this research. But right now I'm collecting some responses from my students back in Thailand, which is in a lot lower level. And I have to look at that one more time with lower level of proficiency from students with a lot of grammatical mistakes. I want to know how the machine would respond to that. And if it's not acceptable, then maybe Google may not be useful.
Thank you, Anne. There is one more question, but I'm afraid we're out of time. So perhaps you could just if you have a chance, maybe you can just address the question at the chat box. For now, I have to end this session. Thank you, Anne, once again for your presentation, and thank you all for being here. Just to remind you all that the next session is a plenary session, a plenary and panel discussion webinar room by Professor Guo Xinyu of the University of Bristol. Hope to see you all there. Goodbye.
Thank you.
Thank you, Anne.